So we have a problem here where we're taking the tangent of the arctangent of 3 plus the arccosine of negative 3/5. What we're going to do is we're going to set the arctangent of 3 equal to alpha, and we're going to set the arccosine of negative 3/5 equal to beta. So the arctangent of 3 is going to equal alpha, and the arccosine of negative 3/5 is going to be equal to beta. Rewriting this means that the tangent of x equals 3, and over here the cosine of beta equals negative 3/5. Not x, I meant alpha over here. There we go. The tangent of alpha is equal to 3. Next, I'm going to look back at what I have up here, but then I'm going to end up with the tangent of alpha plus beta. So I need to know my summation formula for tangent of alpha plus beta. Remember that the tangent of alpha plus beta is equal to the tangent of alpha plus the tangent of beta all over 1 minus the tangent of alpha times the tangent of beta. The tangent of alpha we've already found. We already know that one. So we just need to find the tangent of beta. Well, we know that the cosine of beta is equal to negative 3/5. So from that, we'll be able to figure out what our tangent is. So I'm trying to think of a relationship between cosine and tangent, and there isn't one. There is a relationship between secant and tangent. So remember that secant is the reciprocal function of cosine. So the secant of beta is equal to the reciprocal, which gives me negative 5/3. So then my Pythagorean identity, which incorporates secant beta and tangent beta, is 1 plus tangent squared beta equals secant squared beta. Well, I know what secant beta is. I can go ahead and substitute that in. So I'm going to say that the tangent of beta is equal to the secant squared of beta minus 1, which is equal to negative 5/3 squared minus 1. Squaring this gives me 25/9 minus finding a common denominator, 9 over 9, which gives me 16/9. So the tangent squared of beta is equal to 16/9. Taking the square root of both sides, I end up with the tangent of beta is equal to the square root of 16/9, which is plus or minus 4/3. The next thing I need to realize is that we are doing the arccosine of negative 3/5. When we're talking about the arccosine, the range for arccosine is from 0 to pi. So the arccosine of negative 3/5, this means that I'm going to be in the second quadrant. So in the second quadrant for beta, that means that tangent is going to have to be negative. Tangent is negative in the second quadrant. So we're going to be looking at negative 4/3. So now I know what tangent beta is. I can go back and substitute all these to my formula and come up with what we were looking for originally. So I'm going to take the formula, tangent alpha plus beta is equal to the tangent of alpha, which is 3, plus the tangent of beta, which is negative 3/3, all over 1 minus 3 times negative 4/3. 3 minus 4/3 over 1 times a negative is a positive. These guys cancel out, plus 4. Common denominator, this becomes 9 over 3 minus 4 over 3 all over 5, which gives me 5/3 over 5. Rewriting, that means I have 5/3 divided by 5, which is the same as 5/3 times the reciprocal of 5, which is 1/5, which gives me 1/3. So the tangent of the arctangent of 3 plus the arc cosine of 3/5 equals 1/3. The next problem I'm going to do is the cosine of 2 arc cosine of 25/7. And we need to remember that when we're dealing with our reciprocal functions and we're talking about our inverse functions, we have the relationship that the arc secant of x is equal to the arc cosine of the reciprocal, which is 1 over x. So using that expression, I'm going to go ahead and rewrite this as the cosine of 2 arc cosine of the reciprocal, 7/25. Then I'm going to say that this expression right here, this inverse expression, I'm going to set that equal to theta, and I end up with the arc cosine of 7/25 equals theta, or rewriting that gives me the cosine of theta equals 7/25. Then looking back at the expression I have the cosine of 2, and then I'm going to replace this with theta. So I have the cosine of 2 theta. There are 3 identities I can use for the cosine of 2 theta. The first one is cosine squared theta minus sine squared theta. The second identity is 1 minus 2 sine squared theta. And the third identity is 2 cosine squared theta minus 1. So I could use any one of these 3 identities to solve the expression that I have up here. I already know what cosine theta is. The first 2 identities would involve me trying to solve for sine theta. So I don't want to do that if I don't have to. I'm going to use the third identity. So using the third identity, I have the cosine of 2 arc secant of 25/7 is equal to 2 times cosine theta squared minus 1, which gives me 2 times 49 over 625 minus 1, which gives me 98 over 625. Finding a common denominator for 1 becomes 625 over 625. And then subtracting, I end up with negative 527 over 625.